Hello everyone and welcome to Bhanzu classes. So I hope all of you are doing wonderful and are super duper excited for today's session. So there's a new topic which we are going to pick it up in today's session is operations on rational numbers. So what all are the different mathematical operations which we can perform on rational numbers? That is what we are going to discuss in the session today. But before we move ahead, what all we had learnt in the previous session, it's time to recall that. So we had talked about rational numbers between two rational numbers and also how do we write rational numbers in different patterns. That is what we had discussed in the previous session. So moving on to today's topic, which we are going to learn is operations on rational numbers. So today the operations which we are going to pick are addition and subtraction. So we will be focusing on addition of rational numbers and also subtraction of rational numbers. But we can perform 4 different basic operations on rational numbers, that is addition, subtraction, multiplication and division. So for multiplication and division, which we are going to cater in the next class, today we are only going to focus on addition and subtraction. So I hope everybody remembers the chapter fractions, right? Do you remember the difference between fractions and rational numbers? Fractions are only positive, but if you have a negative fraction, that is where we call it as a rational number also. So actually, rational numbers are positive and negative both, but fractions are only positive. So what all operations we had did on fractions in our chapter fractions and decimals, we are going to apply the same thing over here also. So let's start with addition of rational numbers. So what do we do when we have to do addition of rational numbers? First thing, check out the denominator. If the denominators are same, yes, then what do? Then we should just add the numerators keeping the denominator same. But if in case the denominators are not the same, then what should we do? Then first of all we should take the LCM of the denominators and then we should convert the rational numbers to their equivalent forms. The original rational number to its equivalent form so that we can again add the numerators and keep the denominators same. Got it everybody? Yes. So this is how addition of rational numbers work. So we are going to pick it up one by one when the denominators are same, and when the denominators are not the same, then how should we move ahead for addition of rational numbers. So let's start with the first one where we have rational numbers with same denominators. So here you can see in 7 upon 3 plus minus of 5 by 3, the denominators are same, that is 3. Right? So what do we do in this? First of all, let's have a look with the help of the number line. So in number line, we are standing at 7 upon 3, right? How do we make this number line? Remember, 0. Now 3 by 3 can be written as 1 as an integer. 6 by 3 is 2. If you see this side, minus 3 by 3 is minus 1. So in between, why are we making 3 divisions? Because the denominator is 3. Right? It is same for both the rational numbers. So taking now 7 by 3, which is our first rational number, plus means facing this side. But since the second rational number is negative, so we are going to move backwards, right? Towards the left side. And how many times? That is what we are going to take 5 jumps because the numerator is 5. So the denominator is same, that's why we are focusing on the numerator right now. So when we had shifted back, where do we reach? We reach the number 2 by 3, right? Now if we solve the same thing, so the denominator is same, which is 3, we are taking care of numerator. So 7 plus of minus 5 is 2. Remember the rules of integers. So plus minus is minus. So 7 minus 5 is 2. So we get the rational number as 2 upon 3. So you can see whether we solve it by number line or the basic concept, we get the same answer. So this is how we work when we have the same denominators. Now moving ahead, let's take up this example. Minus 5 by 3 plus 7 by 3. So what did we do? We have just interchanged the position of the rational numbers from the previous one. Now how would this work? Let's have a look at it. So in this rational number, on the number line, if you see, we start from minus 5 by 3 because that's our first rational number. Plus means moving right side, right? How many times? 7 times, ma'am. So 1, 2, 3, 4, 5, 6, 7, and we again reach the number 2 upon 3. So even if you solve it by integers, minus 5 plus 7 catering to the numerators, you would get plus 2 only, and keeping the denominator same, which is 3, right? So we get the answer 2 upon 3. So you can see we got the same previous answer which we got in the previous slide, but here what is happening? This was a plus question, so we shifted towards right, but there we were subtracting, right? It was an addition question, but the second rational number was negative, so we moved backward. So answer is same, but if you see on the number line, the direction of movement changes. There it was on the left side, here it's on the right side. Okay, so moving ahead, let's solve a question over here where the denominators are same. So minus 13 upon 7 plus 6 upon 7. So how do we work? We have to keep the denominator same, right? So keeping the denominator same as 7, let's copy the numerators, that is minus 13 plus 6. So what do we get? We get minus 7 upon 7. But is this the standard form of it? No, they have a common factor of the number 7. So let's reduce it and get the simplest form, which is minus 1 upon 1, which can also be written as minus 1. So the answer to it is minus 1 over here. So got it, everybody? That when the denominators are same, we copy the denominator as it is and we do the operations on the numerators to get our sum over here. Right? Now what would happen if the denominators were not the same? So we have to take the LCM. Remember we had done in the beginning of the session, take the LCM. So here if you see the denominators are different and they are prime numbers. So just multiply them to get the LCM. So what is 5 into 3? It's 15. So how do we make our denominators 15 to get the same denominator? Let's have a look at it. Minus 7 upon 5 into 3 by 3. So that would make my denominator as 15, right? And here minus 2 upon 3 into 5 by 5 would again make my denominator as 3 into 5, which is 15. Got it? So LCM was 15 only, right? LCM was 15 only. Got it, everybody? So now you have the same denominators, and if we are multiplying the denominator by one of the integers, we have to multiply the numerator also by the same integer. So we get minus 7 into 3 is minus 21 and minus 2 into 5 is minus 10. Now let's open the brackets. Minus 21 plus of minus 10 integers, we would get minus 21 minus 10 by 15. So what's that? That is minus 31 upon 15. So again we had made the denominator same and got the answer. How? By adding the numerators. So this is how we work on when the denominators are same and when they are different. Now let's move ahead and do one practice question for this, where you have the denominators as 6 and 11. So they are different. Let's take the LCM. So what's the LCM of 6 and 11? It would be 6 into 11, which is 66. So what should we do now? We should make the denominator as 66 for both the rational numbers. And how can we do that? That is, 6 should be multiplied by 11 in the first rational number, and in the second one, 11 should be multiplied by 6 to get the denominator as 66, which is the LCM. And if we are multiplying the denominator by one of the respective integers, we have to multiply its numerator also with the same integer. Like over here we are multiplying by 11, here we are multiplying by 6. So what do we get? Minus 55 upon 66 plus minus 18 upon 66. So what do we get? We get the denominator common, which is 66 now. So let's move ahead and solve the numerators. Minus 55, now plus of minus, what would it become? Minus 18. So this is how we solve the numerators. Now what to do? Now add the numerators. Both are negative signs, so applying the rules of integers, the sign would be copied as it is and we need to add them. So we get minus 73 upon 66. Got it, everybody? Yes? So now we would be moving on to a different operation, that is subtraction of rational numbers. So what happens in subtraction of rational numbers? Here we do the addition of the additive inverse of the rational number. Which rational number? The second rational number. So we take the additive inverse of it, right? So to be subtracted to the other rational number. So moving ahead, we are going to see this particular question now. So now let's see how do we solve this question when the denominators are not the same. So what do? We have to take LCM over here. So the LCM of 7 and 8 would be 56, right? 8 into 7 would be 56. So how do we move ahead and make the denominators same? So we have to multiply them with the respective integer to get the LCM as the denominator, which is 56. So 5 into 8 in the numerator would give us 40, minus 3 into 7, which is 21, and the denominators are same, so we have taken it as common. So it's 40 minus 21, which is 19 upon 56. So this is how we get our answer for subtraction. But do we have some other way around? Let's have a look at it. But before that, we are going to recall an interesting concept of additive inverse. Remember, what is additive inverse? Additive inverse of minus 2 by 3 would be plus 2 by 3. Yes, 5 by 9 would be minus 5 by 9. So what is additive inverse? Keeping the rational number same, just changing its sign from plus to minus or minus to plus according to what is given in the rational number. But why are we recalling this concept? To know a different way of subtraction of rational numbers. So let's see. So A upon B minus A upon D. So whenever we have to subtract two rational numbers, we can actually do addition of the additive inverse of the second rational number. So if you see this question right now, 5 upon 7 plus minus 3 by 8. So what we had done? We had taken the additive inverse of the second rational number, right? The same question was there in our previous slide also. So over here when we take the LCM would be 56. 7 into 8 is 56. Now multiplying them with the integer which would give the denominator as 56. And then multiplying that same integer with the numerator also. So what do we get? 40 plus minus 21. So what is plus of minus? It's minus. So what do we get? We get 40 minus 21 upon 56. Right? So we got the answer as 19 by 56. Same answer we got even if we have done the addition of the additive inverse. So this is how we do the generalized form of subtraction by adding the additive inverse of the second rational number which we have taken as C upon D in the general form over here. Got it? Yes. So moving ahead, let's solve a particular question over here where we have a mixed fraction minus a rational number. So what do? So first of all, we have to convert the mixed fraction in the normal form, right? The improper fraction. So here 5 into 2 is 10. 10 plus 1 is 11 by 5, right? Minus of minus 1 by 3. So what we can actually do over here, we can add, right, the additive inverse of the second rational number, which is minus 1 upon 3. So its additive inverse would be 1 upon 3. Now we see that the denominators are different. So what should we do? We should take the LCM as 15. So what do we get? We would be getting 15 divided by 5 is 3. So 11 into 3, right? Plus 15 divided by 3 is 5. It's 1 into 5. So what do we get over here? We get 33 plus 5 upon 15. So here we get 38 upon 15. Right? Since our question was in mixed fraction, so you should convert this improper fraction which we got as the answer in mixed fraction. So what do we get? We would get 28 by 15. So our final answer is 28 upon 15 over here. Right? So this is how we get the answer to the question for subtraction. So moving ahead, let's summarize what all we had covered in our session today. We had talked about two interesting operations on rational numbers, that is addition and subtraction. So what do we get in addition? When the denominators are same, just add the numerators and reduce it to the simplest form. If the denominators are not the same, take the LCM and then convert it into equivalent form, and then you should add the numerators. Right? And same thing happened in subtraction also. But in subtraction, we can make the question easy by doing addition of additive inverse of the second rational number. So do practice the questions based on addition and subtraction of rational numbers till we meet in the next class for learning two new operations, that is multiplication and division of rational numbers. Till then, keep exploring and spark your curiosity. Bye-bye.